So on the first day when discussing the syllabus for the course, I had mentioned that the course content has three major pieces to its segments. The first was theory about relational databases. The second had to do with a standard language called SQL, structured query language, that is used to create and manipulate relational databases. And the third major segment of the course was database design, how you go about designing the relations and their interconnections. So right now we are in the theory segment of the course. So we are learning theory associated with relational databases, and the first theoretical topic that we covered was the relational model. We are now about to start discussing the second theoretical topic, and that is normalization. To discuss this topic, I will start off by first discussing with you the motivation for it. That is, why do we do normalization and what does it consist of? Then the rest of the discussion will concentrate on how we go about doing normalization. So why do we do normalization? And to bring that up, I want to revisit an issue that I brought up in the very first class. Namely, I asked the question, why bother even studying database management systems at all? Why not put all the data that you want to manage and store? Why not put it all in one big list and be done with it? Okay. So what is the problem with using lists? So let's look at a very simple example over here. We have a simple list that contains information on students and advisors. Now these advisors are not faculty advisors, but advisors in resident dorms. So you have students with their first name and last name given, their email address, okay, and you also have the resident advisor's name and the email address of the resident advisor. So these are dorm advisors. And the question we are asking is, okay, so this is a very simple situation. You're only storing information about students and their resident advisors, and you're putting it all in one table. So what's the problem with doing that? And let's reflect a bit on what it is that we normally do with databases. So most of the time, you're simply retrieving information from a database. That's typically what happens 90% of the time, or perhaps 80% of the time. However, we also delete information from a database. We change information in a database, in other words, update it. And we also put in new information in a database. So we also insert information. So keep this delete, update, and insert operations in mind, because those are the operations that actually change the content in a database. And all the trouble that arises with having bad data or inconsistent data arises when you try to change the content. Okay, so let's ask ourselves, if we put all our information in one list or one table, do we have any issues with updating, deleting, and inserting information? So let's take a look at that. All right, so let's first take a look at deletion. So let's look at a specific deletion. Let's say Chip Marino, this particular student here, Chip Marino. Let's say Chip Marino drops out of the university. So they've left the dorm, or they didn't drop out of the university, they just left the dorm and they're going to live off campus. So really all I want to do is delete the information about Chip Marino from this list. All I want to do is delete Chip's name, first name, last name, and Chip's email address. But I can't delete part of that information like that. So if I delete Chip Marino, I delete that whole row number 7. Do you see? I delete the whole row. And in the process, the unintended side effect is that Ken Tran, who is a resident advisor, that information is lost. So we have lost the information that there is a person called Ken Tran who is a resident advisor. And the reason we have lost that information is because Chip Marino is the only advisee that Ken Tran has. Okay, Ken Tran has only one advisee, which is Chip Marino. And if we delete Chip Marino, we also lose the information that Ken is a resident advisor. So this is an unintended side effect of the deletion. So this is called a deletion anomaly or the deletion problem. Okay. Now let's look at what issues might arise during insertion. Let's say I have a new advisor, resident advisor in the dorm, whose name is George Green. And all I want to do is add the fact that I have George Green as an advisor and the email address of George Green. So I just want to add this information. And that's going to be problematic because George Green has not been assigned any advisees yet. He's, as of now, not advising any students. And that's perfectly fine. He's just new. Maybe he will be assigned to students in the next week or so. So the reason we can't add George Green is because we don't have any students assigned to him. So this portion of his record on the left-hand side, the advice is blank, and there's no way I can put that information, I can put that record into the list, okay? So I have an insertion problem. The problem arises that I cannot put partial information that I would like to do unless I have complete information about the entire row. I cannot put in information that I need to put in. So that's the insertion problem. Now, if you think of update, suppose I want to make a change. Okay, so let's say James Thompson, whose advisor is Susan Tang. Okay, so that's the advisor of Susan Tang. Now, Susan Tang actually advises two students. One is Terry Huang, the other is James Thompson. So let's say Susan changed her email address from susan.tang to sue.tang. Okay, so unless I make this change in both places, then I will have inconsistent information in the list, in the relation, in the database. So it will say two different things about Susan Tang, and one of those email addresses is going to be incorrect, okay, because it has just been changed. Now, this is a very simple list. Think of George Mason University, which has 40,000 students, and you can imagine the havoc that would be created if this kind of update, insert, and delete problems arise. Okay, so if we put all our information in one list, there are three kinds of problems that arise. Okay, one associated with insertion, one associated with deletion, and the other associated with updating or changing information. And the reason that happens is because of multiple themes. So we didn't mention it up to now, but I think it was fairly easy to see. Even though we have one list, this list really has multiple themes in it. One theme has to do with students who live in the dorm. The other theme is the advisors who advise the students. So there are two separate themes that are living together in this one table. And anytime you have multiple themes in one list, this results in data redundancy, which in turn causes those update, delete, and insertion problem. Okay, so we can see this even further if we expand the list just a little bit. So what we have done is we have kept the student last name and first name and the email address. We have the advisor's last name and we have the advisor's email address, but we're also recording the department in which the advisor studies. So the resident advisor is also a student. We want to write down the department of that student in case we need to contact them, and also the administrative assistant for that department. Okay, for example, you can see that the administrative assistant for the accounting department is Smith. So anytime you see accounting, you also see Smith. That tells you that the administrative assistant for the accounting department is Smith. The administrative assistant for the chemistry department is Chaplin, and so forth. Okay, so we have expanded the list to include a third theme. So we had students, we had advisors, and now we have departments. So there are three separate themes going on, living together in this one list. And again, we have this update, insert, and delete problem. Okay, so so look at an update problem. If Baker, so Baker is the advisor for Matthew Andrews. You can see Baker is the advisor for Matthew Andrews. So let's say Matthew doesn't like Baker and the advisor is changed to Susan Tang. So now Susan Tang will be the advisor for Matthew Andrews. So if I change the advisor last name from Baker to to Tang, I immediately need to change the advisor's email address also from Linda Baker to susan.tang at ourcampus.edu. So I need to make related changes, not just change the last name of the advisor, but also change the corresponding email address. Things get worse if the advisor is changed to Valdez. So let's say Matthew Andrews' advisor is changed from Baker to Valdez. Then it's not enough to change Valdez's email address. Okay, Valdez has a different department. You see, Valdez is from the chemistry department. So I have to move over and change the name of the department and the administrative assistant also. Okay, so one simple change, that is changing the name of the advisor, resulted in a lot of changes that are propagated to other columns, and it's very complicated to keep track of these things if the list gets large. So imagine a list with 40,000 rows and 50 columns. So these changes can propagate and get very complicated very quickly. Okay, so with three themes here, you can see that updating is a problem. You also have insertion and deletion problem. The same thing that you had with the last example. If Chip Marino leaves the dorms and I delete the information for Chip Marino, I also lose the information that Ken Tran is a resident advisor, and I also lose the fact that Rogers is the administrative assistant for information systems, because this is the only row that contains information systems and Rogers in it. So if I delete Chip Marino, all that information goes and I lose unrelated information. So if you think about how this list would work, just the mere fact that it has multiple themes results in this update, insert, and delete problem. So technically speaking, here we are. We say that the reason that we normalize tables is that if we have tables if we put all our information in one table, it will very likely have more than one theme. And when you have more than one theme, you get data redundancies, which create update, insert, and delete problems. The more technical term, sometimes you will hear the term update anomaly. Okay, insertion anomaly, and delete anomaly. Okay, so these three problems can arise, and it is because of these three anomalies that we need to normalize tables which have multiple themes in them. And it's very likely, if you put lots of information, all your information in one table, it's very extremely likely that it will have multiple themes in it. So the fix is to take the original one list and break it up. So going back to the original list where we had student and advisor, we had two themes, students and resident advisors, two themes in that one table. So what we do now is we break up that one table into two tables. We have one table for advisor and we have one table for student. We will see later on how to do this breakup, but essentially the output of normalization is simpler tables where each table really covers about one theme. Okay, so we don't have multiple themes in the same table. So that is the what and the why of normalization. We normalize tables because if we put too much information in one table, and in particular if there are multiple themes in one table, it creates redundancies that results in update, insert, and delete anomalies. To get rid of those anomalies, which will result in inconsistent information in the database, we split the table up into multiple tables that have better properties, that do not have those kinds of anomalies. So that's the end result of normalization. And the mechanics, the process by which you split the tables, is the how of normalization. And that's what we will see in subsequent tutorials.